So a well-kicked soccer ball can have a speed of 40 meters per second. If the kicker's foot is in contact with the ball for 0.3 seconds, what's the acceleration of the soccer ball? And we can assume the ball starts at rest. All right, so what do we have for given information in this problem?
We got the initial velocity.
Yeah, what's the initial velocity, Jose?
0.
Zero. Yeah, because it starts at rest, right? We can assume it starts at rest. Good. Other givens?
The final velocity.
Mm-hmm.
That one is 40 meters per second.
Right, that's 40 meters per second, right? That's how fast the ball is going to be moving after it gets off of the kicker's foot, right? So that's its final velocity. Good. And maybe somebody else, what do we have for the last given here?
We got the delta time too.
Yeah, we got the time, right? It's in contact with the ball for 0.3 seconds, right? Seconds is an amount of time. Yeah. That's how long the ball and the foot are touching each other, right? Okay, so we've got 3 givens, and what are we looking for?
Acceleration.
Yeah. So how much is it going to be accelerating? Okay, good. So next step is to pick an equation, right? If we have the initial and final velocity, the time, and the acceleration, which would be the right equation to pick? Well, only one equation has Vxi, Vxf, delta t, and Ax, right?
Second one?
Yeah, the second one, right? Here's Vxi, Vxf, delta t, and Ax. So the second one is the one to use here. Final velocity equals initial velocity plus acceleration times time. And the unknown here is acceleration, so I do need to rearrange this equation to get acceleration by itself. I can do that in 2 steps. What's the first step I should do if I want to get this piece of the equation by itself?
We have to subtract the initial velocity.
Right, thank you, Jose. We have to subtract the initial velocity. So if we do that, Vxi minus Vxi on that side cancels out. And on this side, we now have V final minus V initial equals acceleration times time. And now there's just one more step to do to get acceleration by itself, right?
You have to divide the delta time.
Yeah, that's right, Isabella. We divide delta time. So that cancels out on this side. And the equation we're left with is acceleration is final velocity minus initial velocity divided by time. Now we can plug in our numbers, right? Our final velocity was 40 meters per second. Our initial velocity was 0. And then we divide that by 0.3 seconds. All right. So that's 40. I'm not going to bother doing minus 0. That doesn't do anything. Divided by 0.3 gives us 133.3, around that. 233 meters per second squared. Right, meters per second squared because we have meters per second divided by seconds, right? Makes meters per second squared. And that's a pretty big acceleration, right? That's bigger than most of the accelerations we've seen so far for things falling or cars accelerating. But when you kick a soccer ball, you're putting a really big force on that soccer ball and it gets up to speed really quick. So that is a big acceleration, but but kicking a soccer ball involves a big acceleration. So questions about how we got that?